Release practice number 3. Katie and Jennifer are playing a game. Katie and Jennifer started each with 100 points. At the end of each turn, Katie's points doubled. At the end of each turn, Jennifer's points increased by 200. At the start of which turn will Katie first have more points than Jennifer? So if they each started out, here's Katie, and here's Jennifer. They each started out with 100 points. And that was on their 0 turn, so they hadn't even started the game yet. After the first turn, Katie's would have doubled, so we're going to times by 2. So she is 200. And Jennifer's increased by 200, so we're going to just add 200 points to hers. So we're trying to figure out at the start of which turn will Katie have more money or more points than Jennifer. So right now she doesn't. So let's look at turn 2. Her points would double at the end of turn 2, so they would be at 400. And her points would add 200 to be at 500. Katie still doesn't have as many points as Jennifer. On the third turn, Katie would get 800 points, and then at the end of the third turn, Jennifer would have 700 points. So when they go to start their 4th turn, Katie will have more points than Jennifer. Number 2, energy and mass are related by the formula E equals mc squared. M is the mass of the object, and c is the speed of light. Which equation finds m given E and C? So essentially we just want to get m by itself. We can look at our answer choices and see which variable is solved for. So in order to undo multiplication, I'm going to divide by c squared, so those cancel, and I'm going to divide the other side of the equal sign with c squared. So the only thing that you're left with is m all by itself, which is essentially the same thing as answer choice D. Number 3, suppose that the equation represents the value of a car from 1964 to 2002. What year did the car have the least value? So we know this is a quadratic equation, and we can type that into our calculator, and we're going to be looking for the least value. So if we'll turn it on and go to y equals, type in your equation. We can either graph it, but it looks like these numbers are kind of large. We could graph it and find the minimum. Okay. Minimum. It says left bound. We're going to scroll to the left of the vertex. Scroll to the right of the vertex. And it's going to give us a minimum of 11,9.7 That's the coordinates that it gives us. My other option, like I said, because my numbers are so large, I could look here in my table, and I could scroll to find which number is the smallest, and it looks like it is right here at 11,975. So why is 11 not an answer choice? Because 11 represents the years since 1964. So we're going to add 11 years, which would give us 1975. Number 4, the table below shows the average weight of a type of plankton after several weeks. What is the average rate of change in weight of the plankton from week 8 to week 12? So I only want to focus on week 8 and week 12. And the average rate of change is just like finding the slope. Change in your y's divided by the change in the x's. The change in my y's is going up 45 hundredths. And the change in my x's is going up 4. So when I divide 0.45 by 4, I'm going to get 0.1125 ounces per week. My paper's apart. Okay. All right. Monica did an experiment to compare two methods of warming an object. The results are shown in the table below. Which statement best describes her results? So we're looking at our answer choices to kind of figure out maybe what exactly is the question asking us. It's asking us to look if it's changing constant or exponentially. And remember, constant is when you are adding or subtracting the same amount each time. Exponential is when you are multiplying or dividing by the same amount each time, which is most of the time where we are finding those percentages of increase or decrease. So here, as the time passes in hours, method 1 looks like it's going to go up by 5 and go up by 6. Then it looks like it goes up by 4. So it doesn't look like there's really a pattern at all in method 1. Method 2 looks like it is multiplying by 2. 3 times 2 is 6. 6 times 2 is 12. Looks like every time here, method 2 is being multiplied by 2. So the temperature using both methods is constant, false. They're both exponential. They're not both multiplying, so that's false. Method 2 changes at a constant rate. It is constantly increasing, but remember, constant is for adding and subtracting, so it's going to be just for multiplying. And then last, just to check it out, method 2, so it's not changing constant. Constant is for multiplication. So the temperature using method 2 is changing exponentially. It's the only one that multiplies. So it is D. I apologize about circling C. And last but not least, the boiling point of water, measured in degrees, represented by the letter T, at an altitude, which is measured in feet, is modeled by this function, T of A. In terms of the altitude and temperature, which statement best describes the meaning of the slope? So it looks like here, my slope is negative 0.0018. Okay? And that is measured in feet and degrees. So the boiling point increases by 18 degrees as the altitude increases by 1,000 feet. So it looks like what they've done is they've changed everything from being into 1 foot to being into 1,000 feet. So what that means is we're essentially just going to multiply our slope by 1,000 to get it for every 1,000 feet. And when we multiply by 1,000, it's essentially moving our place value over 3 times. So it's going to be 1.8. I can eliminate answer choice A and C. And so B says the boiling point increases by 1.8 degrees as the altitude increases by 1,000 feet. Seems like that checks out. D, the boiling point decreases. Oh, just kidding. It doesn't check out because this is negative. Looks like I need to do a little bit more studying myself. So yes, the boiling point will decrease by 1.8 degrees every 1,000 feet.